Hello everybody, welcome to today's live expert session. For those of you who don't know me, I'm Dan Anderson. I'm a clinical specialist working in the UK and Ireland, and I work in molecular imaging. Before we start, I'd like to clarify that everyone can at least hear me and possibly even see me. If you could just let me know in the chat box on your screen, that would be useful. Okay, thanks Pavel. So everything's all okay, so we'll crack on. Okay, so the primary focus of today's session is to demonstrate how the DaTQuant application works on Xeleris 4. We're going to look at the report tool, and we'll look at normal database management. And I anticipate the session will last around 20 to 25 minutes. And we'll leave a few minutes at the end for questions, so yeah, feel free to ask. Okay, so what is DaTQuant? So DaTQuant is an application that provides a platform for the reconstruction of DAT scans and a means of quantifying and comparing DAT scans to a normal population. So we'll proceed to look at the application, and I'll just set that up 2 seconds. Okay, so you should all now be able to see my Xeleris. So to launch DaTQuant, simply you need to select an NM Termo dataset and launch your application. Now before the scan can be reviewed and compared to a normal database, it needs to be reconstructed. So the first step in the reconstruction is the motion detection and correction step. And the scan can be corrected for motion in the X and Y axis. And the detection and correction is automatically initiated upon opening the application. Once the correction has taken place, we need to decide whether we like the original data set on the left hand side or the corrected data set on the right hand side. In this instance there's no movement, so I'm just going to use the original data set. And once the motion detection and correction step is complete, DaTQuant reconstructs the scan as per your customized settings. And the next step is to reorientate your scan. So we want to see that our data is symmetrical. So as well as being visually appealing, having a symmetrical data set will help the iterative registration process. To reorientate the scan, you can manipulate the green crosshair lines. And you can scroll through your data set to see the effect of the manipulation. So once you're happy with your orientation, you can click Past to proceed to the iterative registration process. So the scan needs to be registered into a standard space for comparison to your normal database. The registration process automatically starts once you've done your reorientation. And once the reorientation process has taken place, you need to check your registration in the hybrid QC step. Here you're going to be able to see where the striatum regions have been placed, and you need to check that they've been placed appropriately. If not, you can change them by clicking on the Edit ROIs button, and you'll be able to move your ROI in the X and Y axis simply by clicking and moving. Once you've finished manipulating your region, you can click Accept, or you can click the Reset button, which puts the region back into its original place. So if no manipulation of the regions was necessary, we can click the Pass button. And then the next step would be the Q-check step. So this gives you the opportunity to check the number of counts acquired in the scan. More than 3 million is optimal. And you'll need to input your injected dose and your radiopharmaceutical. I'd like to think that you were using that scan. And once this is done, you can click OK. So now we can go on to analyze the scan. Qualitative assessment can be done on a number of different screens. Firstly, you can look at all your nuclear medicine transaxials. You can look at the MRI template transaxials, the nuclear medicine and MRI fused transaxials, or all transaxials. You can look at your nuclear medicine 3 planes, MRI template 3 planes, your fused 3 planes, or all 3 planes. Once this is done, you might want to go on to look at your quantitative assessment. So that can be done with the table down the bottom that shows a range of statistics. The top row of statistics shows your patients' striatum to background ratios for your striatum, putamen and caudate. The second row would show your normal values. The row below shows how much your patient is deviating from the normal value as a percentage. And the bottom row shows the difference between your patient and the normal population expressed as a Z-score. You can click on the Advanced tab, and that introduces anterior and posterior putamen statistics. Ratios introduces putamen caudate ratios left and right. And asymmetry will introduce striatum, putamen and caudate asymmetry values. In the top right corner of the screen, there are graphs that show the striatum to background ratios against age for your normal patients and for your current patient. The current patient will be shown in red, whereas the normal patients are shown in grey. And by clicking the drop down menu, there are a range of different graphs you might want to look at. So once you've finished the review of your scan, you may want to generate an automatic report. So this is done by clicking Report and Edit Report. Now at this point you may wish to edit exam description, referring physician, reading physician, or you may want to put a brief report in the optional text. And to do this, you need to click on the Edit Report button. And you'll notice that editable fields are boxed in red. So in the red boxes you type your desired text. So I'm just inputting my referring physician, and I might put in a very brief report. And once you've input your desired text, you go back to your Edit Report button, and that disables the editing tool. So the statistics and graphs shown on the report page are the ones that are being viewed on the Review tab. If you want to change these on the report, you need to close the report. Choose the desired graph from the drop-down menu in the top right corner, and change the level of statistics on the bottom of the page. and then reopen the edit report page, and you'll notice that the graph and the stats we're seeing are now in line with what's on the review page. So once you're happy with the report, you can think about exporting it. So this can be done as a PDF. So if you click on the PDF button, a browser will open. You'll input an appropriate name and browser desired destination and click Save. Or you can export it as a DaTQuant screen capture by clicking on the DaTQuant screen capture button. This is going to save your report to the Xeleris database, and from there you can export it to a desired location such as PACS. So once you're done with the report, you can close it. And then at this point you may wish to close the application. Okay, so that was a brief run through on how the application might work. We'll quickly go on to look at normal database management. So as previously mentioned, one of the key features of DaTQuant is the ability to quantify and compare your patient's data to a normal population. The normal population database in DaTQuant was acquired using a range of gamma cameras from different manufacturers through the multi-center Parkinson's Progressive Markers Initiative in America. And the sample in the normal database is of 73 healthy males and 45 healthy females, all of which have no family history of Parkinson's disease. Now, all of the patients in the normal database were scanned using low energy, high resolution collimators. And they were reconstructed in 4 ways. So consequently, we have 4 different normal databases. So there's a normal database for filtered back projected reconstructed data with no attenuation correction and with Chang attenuation correction. And both filtered back projected databases were reconstructed with a Butterworth pre-filter with a factor of 10 and a cut-off of 0.6. And there's also a normal database for data reconstructed with OSEM without attenuation correction and with Chang attenuation correction. The OSEM reconstructions were performed with 2 iterations and 10 subsets. And again, there's a Butterworth post-filter with a factor of 10 and a cut-off of 0.6. Okay, so they're the normal databases that are available to you. And we appreciate that the GE normal databases don't necessarily fit local needs. So it may be appropriate for you to build your own user-defined normal database. And this can be done in DaTQuant, so I'll go on to show you that now. Just 2 seconds. So you should be seeing my Xeleris again. So on the review screen on the Xeleris, we can start thinking about normal database management. So firstly, a patient deemed to be normal should be reconstructed in DaTQuant. And then using the Add button at the bottom of the layout menu, we can think about building our own normal database. So actually, let me just stop right there. When you open DaTQuant, the application chooses a normal database that is in line with the reconstruction that you've performed. You've noticed I've just changed the normal database I was comparing my scan to by using the normal DB drop-down menu. If I change it to something that's not in line with my reconstruction parameter, you will notice you get a normal DB mismatch flag, just to point out the fact that your stats might not be hugely appropriate. Okay, so back onto normal database management. Okay, so to add patients, we click on the Add button. Okay, and firstly we need to build a new database. We give our database a name and a description. Now your name should be in line with perhaps the acquisition you've done or the reconstruction you performed. So in this instance I've put RR for resolution recovery. And once you've done that, you can click OK and click OK again. Now the dialog just confirms that your current patient has been added to the normal database, and you click OK again. Once the user-defined normal database has been created, you can continue to add more patients to the database. So each patient you want to add to the database, you need to reconstruct in DaTQuant. And once the patient is reconstructed, you can click the same Add button used to create the normal database. On the resultant dialog, highlight the database you want to add your patient to, and you click OK. And then you get the same resulting dialog, and you click OK on that again. So once a user-defined normal database is of adequate size, you'll want to publish it so that it can be used in DaTQuant. So to publish your database, you click on the View button. You select the user-defined normal database to be published from the list in the top left corner. And then you would click the Publish Database button. At this point, it's possible to rename the normal database or amend the description of the database. And once these are appropriate, you can click OK. And you would click OK again. So now you'll note that my user-defined normal database is visible in my drop-down menu. So the View dialog is used for more than just publishing your user-defined normal databases. In here it's possible to delete individual subjects from user-defined normal databases. So to do this, we would highlight the normal database we wish to amend. then highlight the subject we want to remove and delete subject. Again, you need to click OK on the dialog box that results of that. It's also possible to delete whole user-defined normal databases in the View tab. So to do this, you would highlight the database you wish to remove, and then you would click the Delete Database button. And once more, it'll be necessary to click OK. In the View tab, you can export your normal database to a CSV file. So to do this, you would highlight your database, and then you would click Export to CSV. And then from here, you would have to browse your eventual destination, give your file a name, and click Save. Okay. So next we're going to look at the Manage tab. So the Manage tab allows you to visualize specifics of a normal database, and this includes the GE databases as well. So if you click on, say for instance, the GE normal database, it will give you individual patient gender and age demographics, as well as acquisition camera, collimator, and reconstruction parameters. In the Manage tab, it's also possible to import and export normal databases in a format specific to DaTQuant. So to export a normal database, select your database, click on Export Database, give your database a name, browse its eventual destination, and click Save. And then equally, to import a database, you click Import Database, browse your file, and click Open. So in the Manage tab, it's also possible to export to CSV and delete database as per the View tab. Okay, and the last feature of the Manage tab is the ability to define a normal database as DaTQuant's default normal database. So to do this, you select your normal database, and then you check the default NDB button. Now this database is your default every time you open DaTQuant. Okay, so that concludes this very brief demonstration of DaTQuant in Xeleris 4. We've looked at how the application works, we've looked at normal database management, we've looked at the report tool. Now this video will be recorded, and I think you will be emailed a link to access it, and at some point in time as well the video will be available on gecares.com. With that in mind, I'd now like to invite you to ask questions using the chat feature. Any questions? So was today's session of use to everybody? I hope so. Okay, so Pavel has asked if there's any differences between DaTQuant standalone and the version I've just shown you. I believe not, Pavel. I think they're exactly the same. That's my understanding of it, including the the reconstruction part at the beginning. So yeah, the two platforms are aligned. Any more questions? Okay. Okay. So I've been asked whether CT scans can be used in the reconstruction. I didn't on that demonstration, but you certainly can. Now, the normal databases don't cater for measured attenuation correction. This might be an instance where you might want to build your own normal database. So Pavel's asked about the supplying of other normal databases. No, in Xeleris 4 and in the standalone version, the database we've just seen is all you'll get. EncDat was available on previous versions, but not this version. So if you have Xeleris 3.1, 3.0, you'll be using the EncDat database, which only had 20 low likelihood males and 17 low likelihood females. So in many respects limited compared to this database, which has 110 patients. Okay. Any more for any more? Okay, I don't think any more questions are coming in. Hopefully you can all see my email address there. If you have any questions, feel free to email me, and I'll more than happily answer. Otherwise, we'll call it a day there. So yeah, thank you very much for joining today. I hope you found it useful, and have a good weekend.